Alright, so we're going to solve this by substitution. We've got negative 6x plus 3y equals 4 and y equals 2x plus 1. So these are two separate equations and we've got to solve for x and y. So our answer should look like, you know, x, y equals something. We need two numbers. We need the whatever x is and whatever y is. So two numbers that we can basically plug into both equations to make them both work. And in fact, I'm just going to, just for fun, I'm going to make that point, but I'm going to do this. I'm going to go, look, at the end of this, we need to go negative 6 times some number plus 3 times some number equals 4. And then some number equals 2 times some number plus 1. So whatever number we plug in for x here and here, and whatever number we plug in for y here and here, should make both equations true. And so at the end of this, we'll hopefully we'll get our answer and we'll go back and plug it in and see if it works, right? So the substitution trick is we got to get a variable, a letter, all by itself, and then we kind of plug that expression in for the letter in the other equation. So you could solve for this x, this y, or this x. And as it happens, look at that. Y is already on its own, right? So to me it makes sense anyway. I don't know how about you guys, but to me it makes sense that you would take that thing and plug that thing in for y. Would that work? All right. So in which case we would have negative 6x plus 3 times this expression, because y equals 2x plus 1. So we can take 2x plus 1 and put it in place of y in that equation equals 4. So we put that there. And now the cool thing, we've now made a new equation, and the cool thing about this new equation is what? How many different types of letters have we got in this equation now? Right. And so if I have an equation with just x in it, I can solve for x. And that's the cool thing. So I should be able to play with this and get, you know, x equals something at the end. That's my goal, right? So at the end of this, solving this, I should get x equals something, right? So I encourage anyone working from home, because I know you all can do this, so anyone working from home and anyone here, just to press pause on the video at this point and just go ahead and solve that for x, because I know you guys know how to do that. So press pause on the video and solve that, all right? So solving this, we do the distributive property first. 3 times 2x is 6x. 3 times 1 is 3. And then obviously write this down, negative 6x plus that equals 4. Now we need to add like terms. Negative 6x plus 6x is 0, or it's kind of like 0x, which is 0, same thing, right? So we get 0 plus 3 equals 4, or just 3 equals 4, right? And so that's what we've got. That is correct. The x's went away. And what we have, this is called a contradiction. And you're supposed to know that if you have a contradiction, that implies that there's no solution to this equation. Okay? Now, I don't know how you guys are going to just memorize that. And some students that tell me, well, it kind of looks crazy, so obviously there's no solution. But what I'd like to do is to kind of show you why there's no solution, right? There's no two numbers, because remember at the beginning we said, okay, what two numbers can we plug in to where the equations will be solved? What can I plug in for x here and here and y here and here to make both equations work, right? So the answer is you're going to find there are no numbers that will work. I mean, that are the same. Remember, you can't just plug in whatever you want. Like the 2 times x, this number here has to be the same as your negative 6 times x here. And the 3 times y, that number has to be the same thing as this number, the y equals. Right? So you won't be able to find any two numbers that work. And here's why. Let's, for fun, take this equation, negative 6x plus 3y equals 4, and we'll go ahead and graph that, right? So we're going to solve that for y. So let's write that down and solve it for y, and then I'm going to graph that on this equation, xy, right? So we're going to add 6x to both sides, right? You got me there yet? So we got 3y equals what? Good. 4. Good. Now to get y in its own, what do I need to do? Divide by... Nope. I want to get y equals something. How do I take a 3y and turn it into y? What do I do to it? Good. So we got to divide that by 3 to get it to turn into y. We have to divide everything by 3, right? Right? So we get y equals... Yeah, 1 1/3 plus... Good. And I'm going to write like this, 2x plus 1 1/3. Good job. Or 4/3, same thing, right? Now if we were to graph that, let's plug in a couple of points. Let's plug in, I'll just plug in 0 and 1 for fun, right? Well, actually, well, yeah, for fun, I'll just plug in 0 and, yeah, 4. How about that? 0 and 4. 0 and 1 would work as well. But in any case, you get, if you plug 0 in, you get 2 times 0 plus 1 1/3, right? Which is 1 1/3. And if you plug 4 in, you get 2 times 4 plus 1 1/3, which is... Yeah, go ahead. Yeah. Yeah. Or are you seeing the... Okay. Okay, good deal. All right. So that is 9 1/3, right? Right. So let's plot these points. 0, 1 1/3 is about here. And then 4, 9 1/3 is about here. And as we graph that, I'll just graph that real quick. But I just want you all to pay attention to the slope. And of course, because I have a fraction there, it's a little bit hard to recognize. Right? Because our other equation was y equals 2x plus 1. Let's do that here. Y equals 2x plus 1. I'll just do a little table for that. X and y equals 2x plus 1. And I'll just plug in 0 and 4 as well, just for fun, right? So for y equals 2x plus 1, what points would we get for these? Every 1, yeah? Yeah, because 2 times 4 plus 1 is 9. Good. So if I was to graph this, it'd be 0, 1, which is just underneath that graph, and then it'd be 4, 9, which is just underneath that graph. So if I was to graph that one, all of the points you're going to find are just a little bit below the black line, right? So we get these lines, and those lines are called parallel, like you say. They're parallel, right? So is there ever going to be a point of intersection? So there's no point of intersection because they will never intersect. There's no point of intersection. They'll never intersect, and that's why there's no solution. And similarly, another way of saying that is there's no x and y point that we can plug in that will make both of these equations work. They just don't exist. You know, like and so there's parallel lines, and we could have identified that pretty quickly at this step here, where we found that the slope of this line was 2x. Because see how the slope was 2, I mean. The slope was 2, right? See how the slope of this guy was 2, right? And we notice on the other one, hey, what's the slope of this line? That's 2. So if you have the same slope, but a different point of a different y-intercept, this one starts at 1 on the y-axis, this one starts at 1 1/3, and they're both the same slope, well, then they got to be parallel, right? I mean, I'll give you guys another example. Like, what if you had something like, really quickly, what if you had y equals negative 5x plus 3 and y equals negative 5x minus 2, right? What do you think the solution is to this pair of equations? Well, tell me about the slopes? Right. So these guys have the same slope, which is negative 5. I just made this up, by the way, just an example, everyone watching from home. Same slope, negative 5, and the y-intercepts are, right, they're different, right? So for example, this guy, we'll call this the red line, starts at 3, and then the slope is negative 5. So you go over 1, down 5, over 1, down 5, and so on. And so that guy goes like that. Right? And this one starts, I'll call this the purple line, it starts at negative 2, and the slope is negative 5, so over 1, down 5, over 1, down 5, and so on. And so you find that these lines are also, they're parallel. Right? So they've got the same slope, but a different y-intercept, parallel lines. And so you can just see that without doing any work. See how I didn't do any algebra? I didn't even, well, I graphed them, I guess, but I didn't even need to, because I saw, hey, they got the same slope, they got a different y-intercept, there must be no solution. See that? So that's something to watch out for. All right. Good work. Good work.